So I made up a fictional data set, but the data set you're working with is an actual data set. Okay. First question is, what are there any data points that are outliers? This is the trend that tends to go down over time. It tends to go down as sunlight increases. The number of incidents of cancer start high as you read the graph from left to right, but they end up a smaller amount as sunlight increases. Okay, so we call this a negative association. So we got a trend. This data point's outside that trend, right? So that's an outlier. So you'd want to identify where that data point happens. At x equals 1, there's an outlier. And then you could, make an estimate for the y value. And you don't have to say x equals 1 either. You could say what the x value is. Like for mine, I just said sunlight because I'm not sure how they measure sunlight, but you could say 1 amps of sunlight. And then y would be, there would be, if this is 20 on the x-axis, then at 1 for a value of sunlight, then we have about 20 incidences of prostate cancer per 100,000 people. And why are they outliers? You could just say because they're outside the trend line. Outliers, there's not a specific formula. There are some people who use a formula, but there's not a mathematical definition that is widely accepted for outliers. So it's just anything that's outside the trend. Part 2, they give us a correlation coefficient. It's negative, but that doesn't mean bad. Okay, a negative correlation coefficient just means it's decreasing as you read it from left to right, which makes sense. Well, I mean, it makes sense based on the scatter plot, but this is a real correlation in the world that more sunlight does lead to less prostate cancer in general. And I guess scientists are still working out exactly why that is. And then here's the equation. Does the least squares regression equation appear to fit the data well? So you would want to take your y-intercept, plot that on the scatter plot. You don't have to necessarily write this down, including your conclusion. And then roughly count out the slope. You don't have to do this for your submission, but you can draw that slope and you should see that it should fit through the data well, because each least squares regression equation is like the best fitting line we can make. The big number you want to point to when answering this is up here. If this is close to -1 or close to +1, then you have a good linear fit. Okay, so for my question, I would say yes, because r is close to -1, which means the linear model is a good fit for the data set. We should say simple linear model. But yeah, it's close. It's a close fit because r is close to -1. And if r is close to +1, then it's a good fit. If r is like 0.3 or 0.2, that's the range where you'd say no. I have a somewhat strong fit because it's closer to -1 than it is to 0.5. If you have an r of -0.5 or an r of 0.5, then that's like a weak fit. It still is a good fit for the model. It's just weak, we'd say. And then part 3 says, what does the least square regression equation predict when the amount of sunlight is 3? All you have to do for this is plug in 3 in for the x variable and simplify. And that's all it would be predicting. So you show me this math and you've got it. But if I change the question, I said, what does the blah, blah, blah when the incidence per 100,000 is 25. This line is talking about the y-axis variable, right? So for this line, I'd be plugging in 25 in for the y variable and solving for x. Okay, so it depends. You've got to make sure you look at the x-axis. Sunlight is my x variable, so I plug in 3 in for x. This one is your y variable, so you'd be plugging in 25 in for y for that one. Okay. And part 4, what does the least square regression equation predict when the sunlight is 5? So here's my data set. That's 1, that's 2, that's 3, that's 4, and then here's where 5 is, let's say, from my made-up data set. Okay. Actually, let's change it. Let's make it even bigger. Let's say 7. The point is, you don't want to make predictions outside the values of your data set. So my x values go between 1 and roughly 4.25, right? To plug in x equals 7 and make a prediction, that's called extrapolation. And we learned in Newton that that's bad. Okay. Extrapolation is where you make a guess outside of your data set using your regression equation. It's bad because sometimes it works, but sometimes it does not work, and it does not work very poorly. So whenever you make a prediction outside your data set, you always want to alert everyone and say, hey, the value we're trying to predict is outside the range of our data set. We don't know what's happening. Maybe the data all of a sudden skyrockets for prostate cancer when you have way too much sunlight. Okay. So for our data set, it makes a linear fit. For x equals 7, we can plug that in and tell them what it predicts, because again, that's an x variable. You plug in 7 in for x, and then you'd finish simplifying. Okay, for both these, you guys know how to finish simplifying, right? You multiply first and then add them together. Get a predicted y value, and then right after, you want to say, no, our prediction is not reliable because it's outside the x values we've been given for our data set.